Hello everyone, this is Aditya and today we study numerical methods in a one go. So let's start with the lecture, but for that please do like, share, subscribe my channel and be support studio. Now let's start. And I have made many one shots for engineering mathematics. Please do check it out. I will give the link in description. So now let's discuss something called interpolation. Let's define it first of all. It is the method of estimating an unknown value or values from a given set of observation. So basically if you are given different observations, then from that if I ask you to find any random unknown value, then finding of that value is called interpolation. Now it can be found using several methods. Let's discuss that. So let's discuss interpolation for equal intervals. What do I mean by equal intervals? For example, if x is equal to 5, x is equal to 10, then x is equal to 15, x is equal to 20, and so on. So there is a constant difference of 5. So it is called an equal interval, and in this the difference is 5. Okay. So to find interpolation in this, what we do is we use two methods. The first one, Newton's forward method, and second, Newton's backward method. So let's discuss both of them using an example. So let's discuss the question. This is the year, that is X, and it is 1891. And these are very common questions. If you see anyone's lecture, you will see that these questions are very common because they are very basic ones, and in your exam also you can find such kind of problems. Okay, so they are very common ones. Okay, so 1891, 1901, 1911, 1921, and 1931, right? And this is population, yeah, fx. It is 46 in 1891, and it is 66 in 1901, and it is 81 in 1911, and it is 93 in 1921, and it is 101 in 1931. Okay, so we have to estimate population in 1895 and 1925. Okay, so how do we estimate it? Well, 1895 and 1925, so we are given 2 years. So first of all, let's solve for 1895, then we'll solve for 1925. Okay, so first of all, let's draw it in a table. So it will be like this. This is x, this is fx, right? So corresponding to 1891, the population is 46. Corresponding to, I should draw it small, 1901, it is 66, and in 1911 it is 81, 1921 it is 93, and in 1931 it is, that's the end, it is 101. Okay, so if you have to estimate for 1895, what we do? Well, 1895 is lying between these two values, right? So to understand the trend, we need to see the forward values, the values which are coming after 1895, right? So because it is lying over here 1895, so you have to see the successive years for its value. That is why we will use Newton's forward method in this, right? And for 1925, it is lying between 1921 and 1931. Hence, this is 1925, right? Because of which we will use Newton's backward method. Why? Because in this we have to see the previous trend, what was how the population was increasing, right? So that is why we will be using Newton's backward method over here and Newton's forward method over here, right? Okay, so now let's discuss Newton's forward method. So first of all, let's complete this table. Okay, so now let's define something called delta fx. Well, delta fx is equal to f of x plus h minus fx. Basically, the successive value minus the value at x. Okay, it means that delta fx is equal to, for example, delta 1891 is equal to f at 1901 minus f at 1891, right? So it is equal to what? 66 minus 46, which is equal to 20, right? Okay. So over here we can write over here 20, right, for 1891, and for 1901 what will be its value? It will be equal to 15, right? 81 minus 66, right? Okay. And similarly for 1911 it will be 93 minus 81, which is equal to 12, and for 1921 it will be 101 minus 93, which is equal to 8, right? So this is delta fx over here. And now let's define another term called delta 2fx. Now how we find it? Well, we find the difference between these two values and these two values and these two values, right? So delta 2fx is basically the difference of these terms. So it will be equal to 15 minus 20, which is equal to minus 5, right? So it is basically minus 5, okay? And what is 12 minus 15? It is negative 3, and 8 minus this quantity, it will be equal to negative 4, right? So the corresponding value to this is I should write over here negative 3 and negative 4, right, in the middle, so it is more understandable, right? Okay. So we can basically say over here that delta 2fx is basically delta f of x plus h minus delta f of x, right? And now delta, this value we all know that it is equal to f of x plus 2h minus f at x plus h minus the quantity f at x plus h minus the quantity f at x, right? Okay. So it is equal to f of x plus 2h minus 2f of x plus h minus plus f at x, right? So if you want, you can just substitute the value. So f at x plus 2h, its value is 81. So it is 81 minus the quantity. Here x is equal to 1891, right? So corresponding to 1891, we are calculating delta 2fx, okay? So 81 minus the quantity 2 times this value 66 plus f at 1891 is equal to 46, so it is equal to, let's add, we will get 127 minus this quantity, it will be equal to what? 132, right? So it is equal to negative 5, right? Similarly we can solve for these values also, correct? Okay, understood. Now let's define delta 3 fx. So it will be equal to delta 2 f of x plus h minus delta 2 f at x, right? So let's solve it also, right? So let's see how we'll find it. So it will be delta 2 f at x, right? Delta 2 f at x, sorry, delta 3. So it will be their difference. So negative 3 minus this quantity, it will be plus 2, right? And this, the difference will be negative 1, correct? Okay. And yeah, that's it. So now let's see the formula of Newton's forward method, right? So f at a plus h u is basically equal to f at a plus u times delta f at a divided by 1 factorial plus u times u minus 1 divided by 2 factorial times delta 2 f at a plus u into u minus 1 into u minus 2 divided by 3 factorial into delta 3 f at a, and so on and so forth, right? So now let's solve. Over here a is equal to 1891 and u is equal to well, just a minute, and h is equal to what? H is equal to the difference. So the difference is equal to what? 10, right? Where 1981 to 1901, it is, the difference is 10, and since it is for equal intervals, so the difference will be same. So h is equal to 10, right? And we have to calculate for a plus hu. We want it equal to what? 1895, right? 1895. Okay. So from this we can solve for u now. What we'll get? U is equal to 1895 minus, what is the value of A? It is equal to 1891. 1891 divided by 10, which is equal to 0.4, correct? So we have all the values just substituted over here. So we have F at 1895 is equal to F at 1891 plus the quantity 0.4 into the quantity delta F at A. What is its value? 20, right? 20 divided by 1 factorial plus the quantity 0.4 times 0.4 minus 1 divided by 2 factorial delta 2 F at A. What is delta 2 F at A? It is equal to negative 5, right? Negative 5 plus 0.4 into 0.4 minus 1 into 0.4 minus 2 divided by 3 factorial times 2, right? Okay. And since we can calculate delta 4 also if you want, so delta 4 will be equal to this minus this will be equal to negative 3, okay? So it will be 0.4 into 0.4 minus 1, 0.4 minus 2, 0.4 minus 3 times the quantity negative 3 divided by 4 factorial. And of course I am not solving it, and of course you will be also having a calculator while solving all these kinds of problems. So I am directly writing the answer. It is equal to 54.852. It's around this, okay? So after that you understood Newton's forward method, right? So this is how basically what you do is that you apply this formula, you find you assume a base value over here, that base value is 1895, okay? And then you apply this formula, you calculate the value of U, and you know the value of H from the differences in the values of the values of X, right? So from that you know the value of U and you substitute the value over here, and consequently you get the answer, okay, when you substitute all the values. So let's move to another not another problem. We are still left with the Newton's backward formula. Let's discuss that also. Now let's discuss for Newton's backward method. Well, F at A plus HU is equal to the quantity F at A plus U times nabla of F at A divided by 1 factorial plus U times U plus 1 divided by 2 factorial. There it was negative U minus 1. Here it will be U plus 1, okay? 2 factorial times nabla 2 of F at A, and again it will be U plus 1 times the quantity U plus 2 divided by 3 factorial nabla 3 of F at A, and so on and so forth, okay? So what is nabla of F at A? Well, nabla of F at X is equal to F at X minus F at X plus H, right? Sorry, X minus H. So over here the base base value is 1931, right? So corresponding to this we will be having these values, okay? Correct. So it means that the nabla, what is the nabla of F at 1931? So 1931, it is equal to F at 1931 minus F at 1921. What is it? It is 1921. So it is equal to 101 minus the quantity 93. It is equal to 8, right? Correct? Correct or not? It is correct or not? It is correct, okay. So 8 and corresponding to delta 2f, the similar formula will be there, right? So negative 4 is the nabla 2 of F at 1931, and this is the value, this is nabla 3 at of F at 1931, and nabla 4 of nabla 4f at 1931 will be equal to negative 3 again. You just calculate nabla 4 on yourself, okay? So basically this is how you calculate the nabla function, okay? And this is not related to something which you study in calculus and all. No, it is a different one, okay? So yeah, this is it. So now let's solve for this 1925. What will be the population? So F at 1925, it is equal to F. Well, first of all we need to find the value of U, right? So again A plus HU must be equal to 1925, correct? What is the value of A? It is equal to 1931, okay? So 1931 plus 10u is equal to 1925. So u is equal to negative 6 by 10. It is equal to negative 0.6. Correct? C. Right? Okay. So it is equal to f at 1931 plus the quantity. Well, I should substitute the value directly. What is f at a? F at 1931, it is equal to 101. So 101 plus the quantity negative 0.6 divided by 1 factorial into nabla of f at 1931, it is equal to 8, right? 8 plus the quantity negative 0.6 into negative 0.6 plus 1, it is equal to positive 0.4. Okay, so it is positive 0.4 divided 2 factorial times the quantity the nabla 2 of f at 1931, it is equal to negative 4, right? So negative 4 over here plus negative 0.6 into 0.4, and negative 0.6 plus 2 is equal to 1.4 divided by 3 factorial times the quantity negative 1, right? Plus negative 0.6 into 0.4 into 1.4 into 2.4 divided by the quantity 4 factorial times negative 3, and of course you can calculate it on yourself. Of course you can't define nabla 5 over here because there will be no value then. Okay, so over here we'll be getting 96 point the 96 point what 8368, so somewhat like this approximate value. Okay, so this is Newton's forward method and this is Newton's backward method. Okay, understood? So when you have to find the value of a function by observing the successive values, the successive results, then in that case you use forward method, and when you have to observe the preceding observations, in that you use Newton's backward method. Okay, so this is it. Now let's move to interpolation for unequal intervals, right? Let's erase this. So let's study interpolation for unequal intervals. Like let me give you an example. Let's solve the question directly. So in this we'll be discussing Lagrange's method. Okay, so let's discuss that. So question, so find value of y at x is equal to 10 by Lagrange's interpolation formula. Okay, so we are given x and y, that is f at x only. Okay, so it is 5 and fx is given 12, 6, 13 and then 9, 14, 11 and then 16. Okay, so that is it. Now we have to find a function at 10. So basically f at 10 we have to find. Okay, so now we can clearly see that 6 minus 5 is equal to 1, but 9 minus 6 is equal to 3 and 11 minus 9 is equal to 2. Hence the difference is not constant, hence it is an uneven or unequal interval, right? So what we do in this is that solution. This is Lagrange's interpolation formula. F at x is equal to, so what you have to do is that you have to just write it like this: x minus 6 times x minus 9 x minus 11 divided by 5 minus 6 5 minus 9 5 minus 11 times function at 5 plus x minus 5, wait, I'm just telling, let me write the formula first of all, into x minus 9 x minus 11 divided by 6 minus 5 6 minus 9 6 minus 11 function at 6 plus the quantity x minus 6 x minus 5 x minus 11 divided by 9 minus 5 9 minus 6 9 minus 11 into function at 11, sorry, function at 9. plus the quantity x minus 5, x minus 6, x minus 9 divided by 11 minus 5, 11 minus 6, 11 minus 9 times the quantity function at 11. Did you observe any pattern? Did you? Well, what I've done is that I first of all I saw this column, okay? Corresponding to x, there was the value f. The f at 5 was 12, okay? So first of all, I considered this column, and I did not wrote 5 over here, right? I just hided this column, so I got 6 values in x. 3 values in x, 6, 9 and 11, right? Okay. So in the first value, what is it? X minus 6. So I taken x and I wrote it x minus 6, x minus 6, x minus 9, x minus 11, right? Now I wrote the same expression x minus 6, x minus 9, x minus 11, but in this I substituted the value of x in the denominator. So x is 5. Whichever term we have missed over here, we have written over here. I mean, I've taken the value which I have not written in this expression in the numerator. There should have been 4 numbers, 4 terms, not terms, 4 terms to be multiplied over basically. But I did not take in this one, so that is why this term x is equal to 5, sorry, due to which I wrote it in denominator, okay, and I took the value of function at 5 and substituted over here, okay. Now similarly I went to the next column, so I hided this column, so I could see 5, 9 and 11, so 5, 9 and 11, and since 6 was hidden, hence I substituted over here. So 6 minus 5, 6 minus 9, 6 minus 11, function at 6. So basically it is x minus, suppose if x is like this, alpha 1, alpha 2 and so on till alpha n, right? And in the middle there lies some alpha k, then any term in this will be given as x minus alpha 1, x minus alpha 2 and so on till x minus alpha k minus 1 times the quantity x minus alpha k plus 1 till x minus alpha n divided by alpha k minus alpha 1 till alpha k minus 1 times alpha k minus 1, sorry, plus 1 till alpha k minus alpha n, okay. So we can clearly see that this is the first term, this is the second term, this is the third term, and this is the fourth term, right? So we can clearly see that there are 4 values of alpha. I mean, alpha 1 is equal to 5, alpha 2 is equal to 6, alpha 3 is equal to 9, alpha 4 is equal to 11. So if I take t2, what will I get? I mean t1, then what I will get? I will get over here x minus 6, x minus 9, x minus 11, divide this, and of course multiply it by a term over here, f at alpha k, right? F at alpha k, right? So this is the basic, this is the general form, okay. And if you want to write it general, to obtain this expression, just do the summation, right? Okay. So this is the general method, how we write a Lagrange's interpolation formula. So basically I hope so that now you understood that whichever column we are choosing, we are not selecting it, and we are just writing different the rest of the numbers like this, and in the denominator we are doing this. We are substituting the value of that number which we neglected, right? And then we are calculating the value of that function at that particular value, right? So now let's solve it at 10, right? So let's see that. So when you substitute the value as 10, you will get 10 minus 6 times the quantity 10 minus 9, 10 minus 11 divided by this quantity. It will be negative 1, negative 4, negative 6. So 24 into 12, right? Okay, negative. And so on for these terms also. Plus, now you can calculate, it is just mathematics. And on solving, you will get 14.66. 14.66, okay? Just substitute the value as 10 over here and you will get your answer. So this is Lagrange's interpolation formula. Now let's move to next topic. So now let's study something called bisection formula or method. So basically it is used to find the solution of an algebraic or a transcendental function, right? What is an algebraic function? For example, x square plus 2x and so on, x cube, 4x square, 4x cube, x to the power 10 and so on. And what is a transcendental function? For example, log x and all, right? So let's see a question to understand this question. Find the real root of x to the power 3 minus 2x minus 5 is equal to 0, right? So we have to find a real root of this this function, right? So it is an algebraic function, right? Function, I mean. So let's see it. So let's define fx as x cube minus 2x minus 5, right? Okay. So now I need to tell you one thing. For example, if there is a function like this, any function, this is the solution when fx is equal to 0, right? Okay, and it is y is equal to fx. So what's the one thing which you can notice? Well, over here the value of function, suppose some a, is negative, right? Okay, and over here the value of function is positive. So we can easily find the solution of a function when it goes from a negative value to a positive value, because it is obvious that in this process it will pass through 0, right? It will, I mean, its value will become 0 at some point, right? Because then it can go from a negative to a positive value, right? It means that to find a solution, f at a it should be less than 0 and f at b it should be greater than 0. And one more thing, if both are positive, I mean, for example, here it is f of b, suppose here it is f of c, right? So in between it is never possible to find a solution, because of course if it in that case the function is like positive only, it hasn't changed its sign, I mean. And if it is negative, in for example here we choose a d over here, right? So in that region also it won't give any solution, because it has the same parity, right? So basically f at a is less than 0 and f at b is greater than 0. So we have to choose such kind of a and b. So for example, let's take f at suppose 2. What we will get? 8 minus 6 minus 5, which is equal to what? It is equal to negative 7, right? It is equal to negative 7, right? And let's take function at b as f at 3. So it is equal to 27 minus 2 times 3 minus 5. It is 27 minus 6 minus 5, which is equal to 27 minus 11, which is equal to 16. So function at 13, function at 3 is positive and function at 2 is negative, right? Now you could have also taken f at 0, there was no harm. F at 0 is equal to negative 5, right? But in the solution I have taken x is equal to 2, sorry, a is equal to 2. So that is why I am sticking to taking a as 2 and b as 3, right? So it is obvious it is going from negative to a positive value, so it is obvious to find the solution, right? In between this region, right? So now let's erase this and let's draw a chart, I mean table over here, right? So this is the number of iterations, and this is a, f at a is negative, and this is b, f at b is positive, and this is x is equal to a plus b divided by 2, and this is f at x, this value. Now notice one thing, that over here we have b and over here we have a, right? So if I take its average, I will come somewhere over here, right? A plus b by 2, right? Okay, I will come closer to this value, right? But I haven't achieved that value. So again I have a plus b by 2 as the next b over here. This is b dash, okay? This is b dash. And which value should I take a? Should I change the value of a or should I keep it same? Well, if I take a as b, is it making sense? No, because it will again be positive and positive, means the parity will become same. But if I take a as the previous one, that is a only, then it is going from again negative to positive one, right? So again we will take the average. We will get a plus 2, sorry, a plus b by 2 whole divided by 2, right? We will get that expression, and we will get closer to this value, right? And like this we will be going. Okay, so now let's see. And yeah, there might come a point when we come over here, suppose at some value a n, right? Suppose at some beta, right? Okay, suppose we come over here. So in this now we won't take this value. Why? We won't take a over here. Why? Because then they have the same parity, so we can't take that. Because if we take average, we will be ending over here, not near there, not near this point, right? So we have to again take the previous region, the previous value. Don't worry, I will be telling you the question, right? So don't worry. So let's see. Let me draw this. So this is it, right? Let me draw this. So this is first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th and 12th. So probably it takes around 11 to 12 iterations to solve. Okay, so a is equal to it, we are taken 2, right? And b we are taken 3. So what is its average? It is 2.5, right? 2.5. Okay, so let me erase this and I will explain you properly over here, right? Okay, so what is the value of function at 2.5? It is 5.625, right? Fx is equal to x cube minus 2x minus 5. You can check these values whatever I am going to write, because I don't know, maybe there might be any calculation error. So if there's any error, so let me know in the comment section, and you should check on yourself also the values. You know the value of function, you know the function basically, right? Now notice that the function is a positive value. So just a minute. So I don't need to draw the y-axis over here. Okay, so suppose this was the origin function. Let's assume it. Okay, so suppose here exists the 0. Now this is the value of function at suppose we don't suppose this is the value of function at 2, right? Okay, and suppose this is the value of function at 3, right? Now when I taken its average, I ended over here. Wait a minute. Suppose f at 3 is over here, this value, and suppose this is 3 and this is f at 2, right? This is 2, right? Okay. So now we can see that suppose that f at 2.5 is a positive value, so it should be lying somewhere over here, right? So f at 2.5, whatever be its value, we have calculated it. So it means that 2.5. So it means that now we have to shift from 3 to 2.5 now. So when we take the average, we'll get more close to this value, right? So now, should I change the value of a? No, I won't change, because the parity is still opposite. So 2 and over here 2.5. Now what is its average? It is 2.25. 2.25. So its value is 1.8906, right? So again it's a positive value. It means that 2.25, it is lying somewhere over here, right? So it is still positive. Hence we won't change the value of a, but we'll change the value of b. We'll take it as 2.25 now, right? So we'll have 2 and over here 2.25. Okay, we'll be having this, correct? Now when we will take its average, we will get 2.125 and the value is 0.3457, right? So it is over here. Let me raise these values. It is 2.125, so it is over here somewhere. Okay, now again it is a positive value. The value of function is positive over here, and the value of function is negative at 2. Hence we will take again this value is 2, and it has 2, it will be 2.125. The average is 2.0625, and when you will solve it, you will get negative 0.3513. Okay, now it has come a negative value. Okay, hence what is its value? At 2.0625, right? So somewhere over here 2.0625, the value of function is a negative value. Now should I change A or B? Well, now if I don't change A and I change the B to 2.0625, then the parity is same, and we can clearly see that there's no solution in this region. So it means that we have to change A to 2.0625 and B will remain 2.125, right? So we will have 2.0625 and here it will be 2.125, right? And the value will be 2.09375, and what is its value? It is equal to negative 0.0089, right? Okay, so now this value is again a negative value, right? So it means it will be somewhat over here, right? Okay, so hence we have to again change the value of A to 2.09375, and it will remain same 2.125, and what we'll get, it is sixth one, so it will be 2.10938, and its value will be 0.1668, right? So now it is a positive value again, right? So it will be over here. Now the value of A will be same 2.09375, and the value of B will be changed now, right? So basically, if the value of function at the average value is positive, then change B because f at B is positive, okay? And if the value of function at this average is negative, then change the value of A, right? Replace the value of A with the average, and if function value is greater than 0, then replace B with this average value. That's it, okay? So 2.0937, 2.10938, what is its average? It is 2.10156, and its value is 0.07856, right? And now just keep on doing this process. Let me write down the chart completely now. Table. So after completing this table, you will get this result, this table I mean. So finally, you can do it on your own because I have told the concept. After that, you can fill on yourself. Now, how to know when to terminate? Well, now after this point, when we wrote the value of the average value, we can clearly see that after this, when we got 2.097, 2.09, this value is constant, right? And in the last three value, it is like very much constant. So x is approximately 2.09. That is the answer, okay? So it is a very lengthy method, of course, and yeah, it takes time, but it's really an amazing method. Now let's discuss another method to do the same problem, right? Now let's study Newton-Raphson method. Newton-Raphson method, okay? So first of all, let me write its formula. It is xn plus 1 is equal to xn minus function at xn divided by f dash at xn, right? Okay. Wait, I'm telling its proof also. So suppose this is, I don't need to draw the y-axis. Suppose this is the function, okay? This is a supposed function, okay? So suppose this is a point, okay? And I draw a tangent to this point. So it will go like this. Wait a minute. Yeah, it will go like this, right? Okay, so what is the equation of tangent? Well, you all must be knowing. Suppose this point is x naught comma y naught, right? So the equation of tangent is y minus y naught is equal to dy by dx at x naught comma y naught into the quantity x minus x naught, right? This is the equation of tangent, and it is not any new equation. It is just equation of a line, of a straight line. The slope is like the derivative at this point, that is dy by dx at x naught comma y naught, This is the slope of this tangent, and this is just this is the point. This is the point form, right? That's it. Okay. So we have y. Now what is it? It is 0. It is, sorry, suppose this value is x1 comma 0, right? So we have negative f at x naught is f dash of x naught is x1, sorry, times x1 minus x naught, right? Okay. Hence x1 is equal to x naught minus f at x naught divided by f dash at x naught. Okay, so we got an expression for this point, right? So we are moving close to this point actually, right? So now what is the value of function over here? So it is x1 comma y1, correct? So now we will draw another tangent, right? So suppose it intersect the x-axis at the point x2 comma 0, right? So similarly over here it is x1 comma y1, so we have x2 is x1 minus f at x1 divided by f dash at x1, right? Correct. Hence for a general point xn plus 1 it will be this expression. Okay, so now let's see it using an example, right? So let's see the same question. F at x is equal to x cube minus 2x minus 5, right? The same question. X cube minus 2x minus 5 is equal to 0, that one. So we are solving it using now Newton-Raphson method, right? So let's see that. So we are given fx is equal to x cube minus 2x minus 5, right? Okay. Now the question is that how we choose x naught. Well, just a minute. So f dash x is equal to 3x square minus 2, right? So how we choose x naught over here? Well, suppose f at 0. What is the value of function at 0? It is negative 5. What is the value of function at 1? It is equal to 1 minus 2 minus 5, which is equal to negative 6, correct? What is the value of function in negative 1? It is equal to negative 1 plus 2 minus 5, which is equal to negative 4, correct? What is the value of function at 2? It is equal to 8 minus 4 minus 5, it is equal to negative 1, right? Okay, and so on. So we choose the value of function. We choose the value of function, I mean we choose the value of x naught such that the value of function is closest to 0. So in all these value I can see that x is equal to 2 is giving the closest value to 0, right? Hence we will choose x naught is equal to negative 1. You can take any number if you want, but it is recommended to choose a number which is which gives the value of function close to 0, right? So that you approach to that value like pretty easily, right? Else it will take more number of iterations, right? So we have x naught is equal to negative 1, right? Okay, so now let's see. The formula is xn plus 1 is equal to xn minus f of xn divided by f dash of xn, correct? Now if n is equal to 0, so we have x1 is x0 minus f at x0 divided by f dash at x0, right? So it is equal to and we can write xn minus xn cube minus 2xn minus 5 divided by 3xn minus 2, right? Okay, so we have what is x naught? It is equal to negative 1. Sorry, it is equal to 2 minus the quantity. When you substitute over here, we have 2 cube minus 2 times 2 minus 5 divided by 3 times 4 minus 2. So it is equal to 2 minus the quantity. What we will get? We will have 4. This is negative 1. Of course, I had calculated over here. Negative 1 divided by the quantity 10. It is equal to 2.1, right? So this is x1, right? Now we will use. You will find x2. It is equal to what? It is x1 minus f at x1 divided by f dash of x1. So just substitute the value. In place of 2, just substitute 2.1 over here in these two, in this and this. So it is equal to 2.1 minus the quantity. When you solve for f at x1, it will be equal to 0.061 11.23, which is equal to 2.094, right? So now let's solve x3. So when n is equal to 2, this was n is equal to 1, right? So when n is equal to this, x3 is equal to x2 minus f at x2 divided by f dash of x2. So if you will solve, it's on you now. You can easily solve, you know the value of x2, just substitute it over here. You will get 2.0945. And when you substitute n is equal to 3, you get x3 is equal to, sorry, x4 is equal to x3 minus f at x3, f dash at x3, which is equal to 2.0945. Now this value is your answer. Why? Because when you again substitute it in x4, I mean when you solve for x5, you will have to substitute this value only, right? So again you will be getting 2.094 only, because you had already substituted 2.0945 over here, and you end up getting this. So when you will again substitute, you will get again the same value, because the function is when you substitute the same value in this function, you will get same output only, right? Okay, that is why. So this is the answer. X is equal to 2.0945, right? So it is the same answer as we got in bisection method also. So it is like it is a better method because it is more efficient, and that method is like lengthy, but that is also interesting. So now let's move to numerical integration, right? Trapezoidal rule and Simpson's 1/3 rule. Let's see that. Now let's study numerical integration. Numerical integration, right? Okay, so let's first of all study trapezoidal rule, right? So if you studied integration, of course you must have studied, so in that you must have studied its proof, that suppose this is a curve, suppose not like this, suppose this is a curve, okay? So suppose this is this is the abscissa value, this is A and this is B, and you draw rectangles, right, like this. This is x1, this A is equal to x0, this is x2, this is x3, and this is equal to xn, correct? Right? Okay, so you make the partitions like this, x0 to x1, x1 to x2, and so on and so forth, right? You break it in different arcs, right? This is your first arc, this is your second arc, this is your third arc, and so on and so forth, right? And you calculate the area of each arc, and then you sum up, right? And you tend n towards infinity, right? Okay, so similarly, integral a to b f of x dx, right? So what is the value of this width? Well, this width is equal to b minus a divided by n, correct? So it is equal to h times y naught plus yn, the number of intervals which you have taken over here. The number of intervals is equal to n, right? N divided by 2 plus y1, y2 till yn minus 1, okay? So this is the trapezoidal rule, okay? And now what is Simpson's 1/3 rule? It is valid for, and yeah, it is valid for every interval, right? Be it odd interval, be it even interval, right? And on the other hand, Simpson's 1/3 rule, right? So it is valid only for even intervals, right? If n is even, right? So it is given as integral a to b f at x dx is equal to the quantity h by 3 times the quantity, since we have Simpson's 1/3, so that is why we have h by 3, correct? Okay, so it is equal to what? It is equal to y1 plus yn plus the quantity, sorry, y0 plus the quantity 4 times y1, y3, y5, and so on, the odd terms over here, plus 2 times the even terms, y2, y4, and so on, right? So we have to basically divide it like this. So basically there must be even number of intervals in this case, right? So now let's see a question to understand this, right? So let's see a question. We have to do it using trapezoidal rule also and Simpson's 1/3 rule also. So integral 0 to 1 upon 1 plus x square dx. Yeah, I know that it is very simple integral. It is tan inverse of 1, which is equal to pi by 4. We all know this, okay? We have to solve it using numerical method, numerical integration, right? So it is, so first of all let's find h. So we all know that we have to use the same set of values in Simpson's one-third rule also. So that is why I will choose n as an even number and as an even interval, right? Because it will be then very much easy. Else if I take odd number intervals for trapezoidal rule and even for this, then it will be like too much calculations, right? So that is why I will take n as even. So problem will be solved, because trapezoidal method is valid for even and odd both, but Simpson's method rule is only valid for even number of intervals, right? So that is why I will take n suppose as 6, right? In the question also it is given 6. If it is not given in the question, then choose according to yourself. Just remember that in Simpson's one-third rule, you have to take the interval even. So if it is not given in the question, just take n as any even number which you want, right? And in the question it is given 6, but still I told that if it is not given, still you can take 2, 4, 6, whatever you want, just an even number, right? And if it is like just for trapezoidal method, you can take 5 also, 7 also, 6 also, whatever you want. But for Simpsons, you have to only take even number of intervals, okay? So now let's solve it. So n is equal to 6. So what is b? B is equal to 1 and a is equal to 0, right? Okay. Hence, what is h? Well, h is equal to b minus a divided by 6, sorry, n. So it is 1 minus 0 divided by 6, which is equal to 1 by 6. Hence, what we have? We have x0 is equal to what? It is 0, this value. X1 is equal to 1 by 6. X0 plus h. X2 is equal to 2 by 6, correct? Are you understanding or not? Xn is equal to x0 plus n minus 1h, correct or not? Correct or not? Sorry, xnh, right? Nh, right? So when n is equal to 1, then we have 1 by 6. When n is equal to 2, we have 2 by h, right? I mean 2 times h. So x3 is equal to 3 by h, sorry, 3h. So x4 is equal to 4h, 4 by 6. X5 is equal to 5 by 6. And x6 is equal to 6 by 6, correct? Now corresponding to this function value, we have y0 is equal to, when you substitute over here, y is equal to 1 upon 1 plus x square. So when you substitute over here 0, you will get 1. When you substitute over here 6, you will get 36 by 37, right? 36 by 37. And when you substitute over here y2, you will get 9 by 10, and over here you will get y3 as 4 by 5, okay? 4 by 5. And over here we will get y4 is equal to 9 by 13, and over here y5 is equal to 36 divided 61, and y6 is equal to 1 by 2, right? So this is the value. These are the values. Now we will apply the integral formula for trapezoidal rule. So what is trapezoidal rule? 0 to 1, 1 upon 1 plus x square dx, right? This is the function, and we all know that integral a to b fx dx is equal to h times the quantity y naught plus y n divided by 2 plus summation I is equal to 1 to n minus 1 y I, right? This is the formula we all know, right? So we have to just apply it over here. What is h? H is 1 by 6 times the quantity. What is y0? Y0 is equal to 1 by 6, and sorry, y0 is equal to 1, and y6 is equal to 1 by 2. So we have 1 plus 1 by 2 divided by 2 plus the quantity 36 by 37, 36 by 37 plus the quantity 9 by 10, this 10. 9 by 10 plus 4 by 5 plus 9 by 13 plus 36 by 61 plus 1 by 2, right? And just add this, you will get the answer as 0.78423, right? This is the final result using this, and pi by 4 is also 0.785, I guess, 7529, I guess, right? Pi by 4. I don't have exact value, it is something like that only, okay? Now using Simpson's one-third rule, 1 upon 1 plus x square dx, it will be equal to, remember, integral a to b fx dx. It is an even interval, hence we can apply Simpson's one-third rule. So it is equal to h by 3 times the quantity y naught plus y n plus the quantity 4 times the quantity y1 plus y3 and so on, plus 2 times y2 plus y4 and so on, right? Okay, so now we have to just substitute the value. We will have 1 by 6 into 3, it is 18. 1 plus 1 by 2 plus 4 times 36 by 37. Y1 is 36 by 37, y3 is 4 by 5. 4 by 5 plus y5 is 36 by 61. What is y2? It is equal to 9 by 10, right? 9 by 10 plus what is y4? It is equal to 9 by 13, right? So 9 by 13 plus the quantity y6, it is equal to 1 by 2, right? So 1 by 2. And when you solve this, you will get 0.785396. So they both are almost same, but still I guess this one is more accurate in comparison to this one. Okay, so now let's move to next topic. Now let's study something called Euler and Euler's modified formula. Let's study that. So first of all, let's start with Euler's method, right? So it is basically used to solve the values of ordinary differential equation at particular points. Let me discuss them. So its formula is y of n plus 1 is equal to yn plus h times the quantity, the function at xn comma yn, right? And yeah, let's see it using a question. And h we all know how to find. We will see it. Okay, don't worry. Solution. Sorry, let's see the question first of all. The question is solve dy by dx is equal to x plus y, and this x plus y is called x n comma yn, right? Okay, this is called fx comma y basically. Okay, so with boundary condition as function at 0 is equal to 1. So basically it is 0 comma 1. So we have to find the approx value for y approx value at for x is equal to 0.1. Okay, for x is equal to 0.1. So now we have to notice one thing, that h is also called step size and n is also referred as number of steps. Okay, so if you are not given the number of steps in the question, you can take on your own, and if you are given, then you have to take that only, of course. Okay, so in the question it is given take number of steps as 5, so I will take 5. Okay, so we are given n is equal to 5 in the question. So what is the final value of x? It is equal to 0.1. And what is the initial value of x? It is 0. Hence b is equal to 0.1 and a is equal to 0, right? Hence we have h is equal to b minus a divided by n, so it is equal to 0.1 divided by 5, which is equal to 0.02. h is equal to 0.02, correct? Okay, so x0 is 0, x1 is equal to 0.02, because we all know that xn is equal to x0 plus nh, right? Okay, hence we have this. So x2 is equal to 0.04, x3 is equal to 0.06, x4 is equal to 0.08, x5 is equal to 0.1. so we have come to 0.1, right? Now we all know that x is equal to 0. We have the value as y0 is equal to 1, correct? y1 is equal to what? It is equal to, from this formula we know yn plus 1 is equal to y n plus h times f at xn comma yn, correct? You have this value, right? So when so let's substitute n as 0. So we have y of 1 is equal to y at 0 plus h times f at x0 comma y0, right? So what is the value of function at x0 comma y0 x0 comma y0? Well, We all know that it is equal to what is y naught? Well, y naught we calculated as 1, right? 1 plus 0.02. Now fx is equal to x plus y. Fx comma y is equal to x plus y, correct? So when you substitute x naught comma y naught, we will have x naught comma x naught plus y naught. What is the value of x naught? X naught is equal to 0 and y naught is equal to 1. So we have 0 plus 1, it is equal to 1.02, right? So it is 1.02. Similarly, y2 is equal to, just substitute over here, n as 1. So it will be 2, it will be 1, and it will be 1, it will be 1. So it will be, what is y1? Y1 is equal to 1.02 plus 0.02. What is f at x1 comma y1? x1 is equal to 0.02 and y1 is equal to 1.02. So we have 0.02 plus 1.02. It is 1.04. Correct? Okay. So this is equal to what? This is equal to 1.0408. So it is 1.0408, right? Now similarly you can solve for these values also. I am writing just the result. So I have written the result. So basically y3 is equal to this. Well, y3 will be equal to y2 plus h times f at x2 comma y2 and so on and so forth. So we have got the value as 1.1081, right? This is the answer. So function at 0 comma 1, sorry 0.1 is equal to 1.1081, right? Euler's modified method. Okay, so in this we define two equations. Y star n plus 1 is yn, this is yn not yn star, okay, plus h times f at xn comma yn, and yn plus 1 is defined as yn not yn star, okay, plus h by 2 times the quantity f at xn comma yn plus f at xn plus 1 comma yn plus 1 star. Okay, this is the equation. Okay, so now let's see the question. Let's see that. So we are given dy by dx is equal to x square plus y and f at 0 is equal to 1. So we have to find f at 0 comma 0 point, f at 0.04. Okay, so now we are not given the number of steps over here, so we can take any number of steps. So probably I can see over here 0.04, so I can take the number of steps as 2 because already the value, the difference is very small, so I can take the number of steps as low. So let's take n as 2. So x final is equal to b is equal to 0.04, x initial is equal to a is equal to 0, hence we have h is equal to b minus a divided by n. So it is equal to 0.04 divided by 2, which is equal to 0.02. This is the step size. Step size is equal to 0.02. Okay, so we have got the value of h as 2, right? As h is equal to 0.02. Correct. Now let's calculate x0 and x1, and so x0 is 2. Is 0. X1 is 0.02 and x2 is equal to 0.04, right? 0.04. So probably we'll be getting the answer when we will solve for this, right? Of course we'll get answer then. So x0, y0 is equal to what? It is equal to 1. Now y1, well, y1 is equal to y0 from this one plus 0.02 divided by the quantity 2 times the quantity f at x0, n is equal to 0, right? F at x0 comma y0. So what is fx comma y? It is equal to x square plus y, right? Okay, so 0 square plus 1, so it is 1 plus function at 1 comma x1 comma y1 star, right? Now what is y1 star? Well, let's calculate this now. So now here it will be f at, what is x1? X1 we have got 0.02 comma y1 star, right? Now we don't know the value of y1 star. Well, now over here we know this equation. Now let's substitute 0 over here. So we have y1 star is equal to y0 plus h times function at x0 comma y0. Correct? We will get this. Okay. So what is y at 0? Well, y at 0 is equal to 1. Y at 0 is equal to 1, right? Okay. Plus 0.02 times the quantity f at x0 comma y0, it will be equal to x0 square plus y0. What is x0? It is equal to 0. What is y0? Is equal to 1. So we have 1 over here. So we have this as 1.02. So this is 1.02. 1.02. Correct? Understood? Okay. So now let's solve for this. So we have 1 plus 0.01 times the quantity 1 plus 0.02 whole square 0.02 whole square plus 1.02. So we will get over here what is the value of y1? Let me see it. Well, the value of y1 is equal to, when we solve it, we will get 1.0202, right? So this is the value of y1. Okay. Now let's solve for y2, and that is what we need to find, y2, right? So it is equal to 1.020, right? Now what is y2? Well, y2 is equal to y1, we know the value of y1, plus 0.02 divided by 2, which is equal to 0.01 times what is over here? It is I've written over here f of x1 comma y1, right? So it is equal to x1 square plus y1. What is value of x1? Well, x1 is equal to 0.02, and what is y1? Y1 is equal to 1.0202, right? So I can write over here it as 0.02 square plus 1.0202 plus function at x2 comma y2 star, x2 comma y2 star, right? Now how we find y2? Well, y2 star, we know this expression. So now we have y2 star is equal to what? Y1 plus h times function at x1 comma y1. So it is equal to this value is 1.0202 plus 0.02 times the quantity x1 square. What is x1? x1 is equal to 0.02. 0.02 whole square plus the quantity 1.020, this 1.0202. So on solving, what we'll get y2 star is equal to what? It is equal to 1.0406, right? So we got the value of y2 star from here, right? So it is 1.0406, correct? Okay. So now let's solve for y2. So what is y1? It is equal to 1.0202, right, plus this quantity. So on solving this, it will be 0.04 whole square plus 1.0406, correct? And on solving, we'll get 1.0408. This is the answer. So function at 0.04 is equal to 1.0408, right? Correct? Not function over here, the value of y, right? I should write over here y, or I should change the function. Okay, I should write over here some y at 0. Why? Why? Because I've already used the function f. Sorry, I forgot that I had used it already. So it will be y at 0. Wherever I've written like this, please note that. Okay, so y at 0.04 is equal to this expression. Okay. So this is the end of this lecture, and I hope that you enjoyed this video. And yeah, I have already made many one shots on engineering mathematics, so you should check out those one shots. And I probably have completed the whole engineering mathematics. Whatever is required for your university or college level, I've completed everything in that. So it is like 25 hours playlist or 26 hours playlist. In that, I have covered everything from first year to second year, whatever is required. I mean, whatever is required in engineering mathematics, I have covered it. Okay, in those playlists for your first semester, second semester, third semester, and whatever maths. If there's some higher level mathematics required, I will make some topic wise videos then. And rest everything I've covered, the overall portion I've covered of engineering mathematics. So from now I'll make topic wise videos for engineering mathematics or bachelor or BSc mathematics, and I'll now start with masters mathematics, and of course I have to cover many topics of physics also, so I will cover that also. So till then, bye bye, take care, and all the best.